Okay, let's dive into this. Welcome to today's Explainer, where we're embarking on a truly fascinating journey. We're going to look at one of the most defining characteristics of all human history, and that's our relentless drive to overcome bottlenecks. Whether we're talking about the physical constraints of just moving around a busy city or the invisible, highly complex limits of global data processing, human innovation is essentially the story of scale and efficiency. Today, we're tracing that exact roadmap. We're going to start with tangible, everyday objects and scale all the way up to the cosmic limits of artificial intelligence. It's going to be a fun one. To make sense of this massive leap, we've broken our journey into 5 key stages. First, a legacy of physical design. Second, the modern intelligence network. Third, the new titans of AI. Fourth, AI's looming energy bottleneck. And finally, building the cosmic frontier. All right, let's get right into it.
Section 1. A legacy of physical design, solving tangible bottlenecks. Because before we can even talk about scaling out into space, we really have to ground our narrative in the physical world.
If we look back at British design history, we see this constant, ongoing battle against friction. Right? In the 20th century, as cars totally took over the roads, public information was just a chaotic bottleneck. The solution was a highly legible, standardized system of national road signs that dramatically scaled up public safety. Fast forward a bit, and the bottleneck shifted to information processing. Brilliant industrial design pioneered affordable personal home computing, literally bringing digital power into our living rooms. By the early 21st century, urban mobility was the big friction point, which was brilliantly solved by ingeniously designed folding bicycles that totally transformed multimodal travel. And today, we see this evolution culminating in user-centric tech ecosystems. In every single era, design takes complex daily friction and turns it into a streamlined solution for the masses.
And this brilliantly illustrates the transition. It's fascinating. We've evolved from mastering physical space, think of the iconic architecture, the tall structures like Big Ben, and the tangible infrastructure of historic London, to mastering completely invisible networks. Today's modern UK innovation hotspots aren't just physical monuments, they're digital-first hubs, like the Oxford-Cambridge Arc, Greater Manchester, and Scotland's innovation centers. The bottleneck isn't moving people around anymore, it's moving ideas and accelerating AI-driven discovery across a massive, connected national network.
Section 2. The Modern Intelligence Network, Scaling Global Security. That invisible connected network brings us right into our next phase, shifting into geopolitics. See, when the bottleneck becomes global threat detection, a single nation's capabilities just aren't going to cut it. You have to scale. Enter the Five Eyes Alliance. This is a formidable global intelligence-sharing partnership between the UK, the USA, Canada, Australia, and New Zealand. By linking these nations together, they've basically created the ultimate tool for rapid data exchange. It's this vast scale of modern intelligence cooperation designed to seamlessly pass vital security data across the entire globe. So why is this massive scale so necessary right now? Well, the data shows over a 50% increase in hostile activity against UK defense from state actors like Russia, China, and Iran. We're looking at threats that range from espionage and cyber attacks all the way to electronic warfare. To handle this huge bottleneck of incoming threats, organizations rely on global hubs, like RAF Witten's Pathfinder building. Inside, dedicated units like the Defense Counterintelligence Unit, or DCIU, are rapidly scaling their response to counter espionage, sabotage, and cyber threats to our armed forces. To actually execute this strategy, intelligence has to flow through a highly structured pipeline. It's super methodical. Step 1, raw data undergoes rigorous analysis. Step 2, it's immediately locked down with robust security protocols. Step 3, that secured data is then leveraged for high-level global cooperation through alliances like Five Eyes. And Step 4, it's ultimately shaped into a controlled media and communications strategy. It is a remarkably efficient engine for processing human and digital intelligence, and it directly shapes modern warfare readiness. Section 3. The New Titans of AI. The Digital Bottleneck. Now, what's really interesting about this slide is that our story takes a major pivot here, because the era of a single, general, best AI model, that's officially over. Software developers quickly realized that a one-size-fits-all AI is just incredibly inefficient. Trying to make one model do absolutely everything creates a massive computational bottleneck. The solution? Specialization. We've taken raw, sprawling software and turned it into distinct tools engineered for exact, real-world workflows. We now have an entire generation of flagship models acting as highly specialized experts.
We basically have three distinct personas leading the pack today. You've got Gemini 3 Pro, the versatile communicator, which is the absolute crowd favorite for daily chat, visual analysis, and user-facing apps. Then there's Claude Opus 4.5, the engineering specialist. This is the one you want for complex, long-horizon coding projects and actually shipping working software. And rounding it all out is GPT 5.2, the reasoning powerhouse engineered purely for abstract reasoning, hard math, and solving complex puzzles with limited prior knowledge. Each Titan acts as a highly specialized expert in its own unique domain.
And the benchmark scores prove exactly why this specialization matters so much. When it comes to multimodal understanding, like interpreting charts and video, Gemini 3 Pro takes the lead with a solid 81%. But if you need to fix real-world GitHub issues and write actual code, Claude Opus 4.5 is the undisputed leader at 80.9%. Meanwhile, GPT 5.2 takes this massive generational leap in abstract reasoning, scoring 54.2% on the ARC AGI 2 benchmark, leaving the others completely in the dust. The takeaway here is simple, but absolutely crucial. To maintain efficiency, you must deploy the right tool for the job.
Section 4, AI's looming energy bottleneck, the physical limits of compute. Wait, what? Just as we've solved the software bottleneck by creating these amazing specialized AI titans, we hit a brick wall. We have to shift from abstract digital software right back to the brutal physical realities of powering these massive models.
This number right here is the absolute core of the problem. Global AI demand is experiencing roughly 100 times growth. 100 times! Our computational needs are exponentially outpacing our traditional terrestrial energy infrastructure. The models are getting much smarter, for sure, but they are also getting incredibly hungry.
The immense computational friction generated by modern data centers and industrial infrastructure is literally radiating heat. We are quite literally burning through our terrestrial power grid. This massive energy crisis currently looming over the tech industry represents a hard physical limit to how much further we can actually scale AI here on Earth.
Section 5. Building the Cosmic Frontier, Off-World Scalability. And this brings us to the final and, frankly, mind-bending layer of our narrative. If the bottleneck is Earth's energy and space, the solution requires us to look beyond our own planet.
Let's move to and see how this builds into an incredible sci-fi-sounding roadmap that's actually designed to overcome our energy crisis. Step 1, orbital scalability, literally deploying AI compute hardware directly into space to harvest continuous, unfiltered solar energy. From there, the vision expands to Step 2, a lunar industrial complex, establishing moon-based factories for rocket-free launches. And ultimately, Step 3, we're aiming for a Type 2 civilization, targeting over 100 terawatts of compute power generated entirely among the stars. No way, right? It's wild!
So pulling it all together, we are staring at a completely surreal vision of cosmic infrastructure. We started this explainer looking at how humans solved the friction of daily life with things like standardized road signs and folding bicycles, right? Then we scaled that up to global intelligence networks and then to highly specialized AI models. But the sheer demand of that intelligence has pushed us to the very limits of our own planet, bringing us right to the threshold of computing among the stars. It leaves us with a profound final thought for today. Is humanity's ultimate technological destiny to leave Earth, not just to explore the unknown, but simply to sustain the insatiable appetite of our digital minds? It's a massive question, and one that really redefines what human innovation truly means. Thank you so much for joining me today on this explainer. Keep questioning, keep learning, and I'll catch you next time.